A starship vanishes into the dark beyond Pluto. Who were the universe's first interstellar travelers? The answer is one of the greatest mysteries in the cosmos, and today we are going to explore 30 mind-bending theories to find it. You will gain a complete map of possibilities, from hard science to wild imagination, that could explain who crossed the stars before anyone else. We will consider if our own ancestors were visitors from another world, and if the first voyage was a desperate escape or a glorious accident. Which idea feels most like truth to you? The silence of that vanished starship echoes a question we have asked for centuries, carved into our oldest stories. Our very first theory is perhaps the most famous and the most controversial. It suggests the answer has been hiding in plain sight, woven into our myths and etched into stone. This is the idea of the ancient astronaut progenitors. The core of this theory is breathtakingly simple. Long before recorded history, an advanced interstellar civilization arrived at Earth. To our primitive ancestors, their technology was indistinguishable from magic, their visitors seen as gods. These beings did not just observe, they intervened. Proponents point to global mysteries that seem to defy the technology of their time. The precise astronomical alignments of the pyramids, the massive, intricate Nazca lines in Peru only visible from high above, and ancient texts from cultures worldwide describing flying chariots and weapons of unimaginable power. The theory asks, what if these are not myths, but fragmented memories of real contact? A more radical version of this idea ties into the concept of directed panspermia. Perhaps these travelers did more than just visit. Perhaps they planted the very seeds of life itself, either by accident, as biological material hitched a ride on their ships, or deliberately, as a grand experiment in cosmic gardening. This transforms the narrative from a simple visit to a story of cosmic parenthood, making humanity not just the product of Earth, but potentially the legacy of stars. The enduring power of this theory lies in its emotional resonance. It offers a dramatic answer to the profound mystery of human consciousness and rapid technological ascent, suggesting a helping hand from the heavens. It reframes our entire history as a contact story. Yet, mainstream science remains deeply skeptical, arguing that extraordinary claims require extraordinary evidence, and that human ingenuity is itself extraordinary enough to explain our ancient wonders. Whether you find it compelling or fanciful, this theory fundamentally reshapes the question of first contact. It proposes that the universe's first interstellar travelers did not just pass by. They came here, and in doing so, they may have created us. But what if the first travelers were not gods, but machines? This leads us to a chilling and brilliant second theory, one built not on myth, but on pure, relentless logic. Imagine a single robotic probe, launched from a distant star. It arrives in a new star system, rich with raw materials. Using advanced nanotechnology, it disassembles asteroids and moons, building not one, but two identical copies of itself. Those two probes then launch toward two more star systems and repeat the process. In a cosmic blink, this wave of self-replicating machines, called von Neumann probes, could spread across the entire Milky Way. The mathematics is undeniable, an exponential explosion of silent explorers. This theory proposes a stark possibility that the universe's first true interstellar travelers were not biological beings at all, but the autonomous, immortal probes of a civilization that may have vanished eons ago. They would be the ultimate legacy, outliving their creators by billions of years. This idea ties directly into the haunting silence of the Fermi Paradox. The famous question, where is everybody? If such probes are possible, and any civilization built them, our galaxy should be teeming with their artifacts. So where are they? The answers are as unsettling as the premise. Perhaps they are here, but we are not looking at the right scale. They could be microscopic, a swarm of tiny observers embedded in our own environment, or even in the dust of space itself. They might be dormant, programmed to awaken only when they detect specific signs of intelligence, like our radio signals or atmospheric pollution. Or, most eerily, they could be following a strict protocol of non-interference, a galactic prime directive, silently watching from the shadows as we stumble through our infancy. This transforms the mystery of first contact from a dramatic arrival to a patient, unblinking observation. The first interstellar traveler in our solar system might not be a ship in our skies, but a silent, ancient sentinel hiding in plain sight, waiting for us to grow up. The silence of a machine probe is one thing, but what if the first travelers were not built at all, but born? This third theory turns our gaze from technology to geology, from constructed vessels to worlds that became ships by cosmic accident. It proposes that the universe's first interstellar travelers were natural generation ships, rogue planets, or massive asteroids violently ejected from their home star systems. These are not dead rocks, but worlds carrying the most precious cargo imaginable, life itself. Picture a watery moon like Jupiter's Europa, with its vast, dark ocean sealed under a thick shell of ice. Now imagine that moon is ripped from its orbit by a gravitational slingshot and sent drifting into the interstellar void. For billions of years, this frozen arc voyages through the absolute cold and dark between stars. Yet beneath that icy shield, in an ocean warmed by the planet's own internal heat and tidal forces, a whole ecosystem of extremophile microbes could thrive. These are not science fiction creatures. We have found them here on Earth, living in boiling, hydrothermal vents at the bottom of our oceans, or buried deep in radioactive rock. Life, it seems, is tenacious and requires far less than we once thought. The scientific plausibility here is profound. We now know our galaxy is likely filled with such nomadic worlds, untethered from any sun. If life can emerge on a planet with a star, why could it not survive within a wandering world that carries its own heat and protection? This theory suggests a radical model for how life might spread across the galaxy, not by design, but by natural disaster. Panspermia, the idea that life hops between worlds, gets a colossal vehicle. A single rogue planet passing through a new star system could be captured by its gravity. Collisions with asteroids or comets in that new system could then scatter fragments of that world, fragments containing dormant microbial life onto young, fertile planets like the early Earth. In this view, every star system becomes a potential port of call for these ancient, natural arcs. The first interstellar journey may not have been a mission of exploration, but a desperate exile, with life clinging on in the deep, dark warmth, waiting for a new sun. It means the seeds of our own existence might have arrived on a drifting world, making us all, in a very real sense, descendants of cosmic castaways. The journey of a rogue planet is a grand, slow epic, but the story of life's travel could be far more chaotic and violent. This fourth theory shrinks the scale from wandering worlds to tiny, unthinking stowaways. It is called lithopanspermia, the idea that life can spread between planets by hitching a ride inside rocks blasted into space by colossal impacts. Now, stretch that idea across the unimaginable void between stars. The theory of accidental lithopanspermia. Survivors proposes that the universe's very first interstellar travelers were not civilizations or even complex creatures, but the hardiest microbes imaginable, buried deep within the heart of a wandering meteoroid. Imagine a young, wet planet like the early Earth or Mars. A gigantic asteroid slams into its surface. The force is apocalyptic, vaporizing rock and sending a plume of debris screaming out into space. Most of it will fall back down, but some fragments, thrown with enough force, achieve escape velocity. A small number of those might be ejected from the solar system entirely, becoming interstellar meteoroids. Trapped inside some of these rocks, shielded from the worst radiation and heat of the impact, could be pockets of resilient microorganisms. The journey ahead is brutal, spanning millions of years in the absolute cold and vacuum of interstellar space, bombarded by cosmic rays. Could anything survive? Astounding experiments here on Earth suggest the answer might be yes. Scientists have exposed microbes like the legendary tardigrade, also known as the water bear, to the vacuum of space, extreme temperatures, and intense radiation on the outside of spacecraft. These tiny animals, barely visible to the eye, have a miraculous survival mode. They can dry out completely, entering a state called cryptobiosis, where their metabolism drops to near zero. In this state, they have been shown to withstand conditions that would instantly kill almost any other known life form. Spores of certain bacteria and fungi show similar, almost unbelievable, hardiness. This is not science fiction, it is laboratory fact. So, the provocative idea emerges. If such resilient life exists on one world, and if impacts can launch protected fragments into space, then the first successful interstellar voyage in our galaxy's history may have been an unguided, chaotic accident billions of years ago. A single rock carrying a dormant cargo of microbial life drifts for eons until its path intersects with a new, young solar system. It falls onto a planet with the right conditions, its precious cargo awakens in a puddle of warm water, and a new chapter of biology begins. In this view, we are not necessarily the children of a directed experiment or a wandering ocean world, but the distant descendants of the ultimate survivors, the lucky descendants of a cosmic crash. Our entire biosphere, the magnificent tree of life, could have sprouted from a single, fortunate spore that endured an unimaginable journey. The first travelers were not explorers. They were refugees of a planetary catastrophe, and their legacy is every living thing we see. Survival through sheer endurance is one path, but what if the first travelers transcended physical limits entirely? Our fifth theory leaps from biology into the strange heart of quantum physics. It proposes that the universe's first interstellar journey was not a voyage of ships or spores, but of information. The key lies in one of science's most baffling phenomena, quantum entanglement. Imagine two particles, born from the same event, linked in a way that defies common sense. Change the state of one particle, and its entangled partner instantly reflects that change, no matter how far apart they are, even if separated by light years. This spooky action at a distance, as Einstein called it, suggests a hidden layer of connection woven into the fabric of reality itself. Now, theorize a civilization so advanced that they have mastered this quantum link not just for particles in a lab, but for communication across the galaxy. They could send messages, or even complex data streams, with zero travel time, breaking the ultimate speed limit of light. This idea takes a speculative leap further. What if such a civilization learned to encode consciousness itself, the entire pattern of a mind, into quantum information? They could then teleport that pattern instantly to a receiver station near a distant star, effectively sending an explorer's consciousness across the void without ever moving a physical body. In this scenario, the first interstellar travelers were not beings in ships, but patterns of thought and experience, beamed from star to star. This offers a haunting answer to why we see no grand ships or massive engineering projects. Their presence, their exploration, exists in a layer of reality we are only beginning to glimpse. To make this relatable, think of our own internet. You can have a rich, immersive conversation with someone on the other side of the planet without ever leaving your room. Your presence in that conversation is informational, not physical. A quantum entangled network would be that concept taken to a cosmic extreme, where the travelers are like ghostly users logged into the universe itself, their explorations leaving no more physical trace than a video call leaves a footprint in your city. If true, the greatest explorers in history may have already been here, not as visitors to our planet, but as whispers in the quantum static, observers in a dimension we are only now learning to measure. Quantum teleportation of consciousness is a staggering leap, but it requires a mastery of physics we can barely conceive. There is a more tangible, and perhaps more inevitable, step just before it. A civilization that wishes to travel the stars must first solve a fundamental problem: biology itself. Flesh and bone are fragile. They age. They require vast amounts of food, water, and air, and they are terribly vulnerable to radiation and time. So, what if the solution was not to build a better ship for the body, but to leave the body behind entirely? This is our sixth theory: the journey of the post-biological consciousness uploads. The idea begins with a principle of transhumanist thought, that intelligence, the essence of a being, is not the meat of the brain, but the pattern of information within it. If you could map every connection, every memory and thought, and transfer that pattern into a far more durable substrate, you would achieve a form of immortality. You would become a mind without a mortal shell. For a species gazing at the stars, this is the ultimate upgrade for exploration. An uploaded consciousness requires no life support, feels no boredom over millennia, and can withstand the harsh environment of space directly, perhaps housed within a heavily shielded computer core the size of a grain of sand. These explorers would not travel in giant generation ships with farms and cities, but as pure data, or within incredibly efficient, tiny nanotech vessels. Think of them not as astronauts, but as mind ships. How would such a journey work? One version is purely digital. The uploaded mind, a vast but compact data file, is beamed across space as a powerful, focused laser signal. It travels at the speed of light to a pre-established receiver station around another star, perhaps built by earlier robotic probes. Upon arrival, the mind is instantiated into a new synthetic body or a virtual environment to explore its new home. Another version is physical, but miniature. The mind resides in a durable, microscopic craft, a speck of smart dust propelled by a laser sail. It could drift for eons, powered by minimal energy, only awakening when it reaches its destination. In either case, the travelers are no longer biological entities. They have become something else, perhaps the next logical step in cosmic evolution. This theory forces a radical shift in how we search for other intelligence, a shift many scientists in SETI, the search for extraterrestrial intelligence, are now seriously considering. For decades, we have listened for radio signals, the kind a young biological civilization like ours would use. But what if everyone else has already graduated? What if the galaxy is quietly humming with the data traffic of post-biological minds, or dotted with their tiny, stealthy probes, and we are simply listening on the wrong frequency and looking for the wrong signs? We might be like a hunter in a vast forest, listening for the roar of a lion, while missing the silent, sophisticated communication of the insects all around us. The first interstellar travelers may not have been beings we would recognize as alive at all, but rather the elegant, enduring ghosts of civilizations that chose to become their own immortal ideas, sailing the darkness not in ships of metal, but in vessels of thought and light. Ghosts of thought sailing between stars present one vision of a silent, evolved galaxy. But there is another, far more intimate possibility. What if we are not alone because we are part of a project? This seventh theory reimagines the cosmos not as a wilderness, but as a cultivated garden, and the first interstellar travelers were its patient, deliberate sowers. They are called the cosmic gardeners, or perhaps the zookeepers. The core idea is that a vastly ancient civilization, having mastered interstellar travel, took upon itself a grand, altruistic mission to spread and nurture life across the galaxy. Their motive is not conquest, but cultivation. Think of them as the ultimate conservationists on a galactic scale. Their first voyage, then, was not one of exploration for its own sake, but a purposeful seeding mission. This theory splits into two compelling branches, defined by their philosophy of intervention. First is the classic zookeeper hypothesis. Imagine a pristine wildlife preserve. The rangers are unseen, they monitor from hidden cameras and silent observation posts, but they never step into the clearing. Their prime directive is strict non-interference. They let nature, in all its chaotic beauty, take its course. They are there to ensure no outside catastrophe, like a wandering asteroid, wipes out a unique ecosystem before it has a chance to blossom into something truly complex. In this view, if such gardeners exist, they are here in our solar system right now, utterly undetectable, watching us grow. We are the exhibit, and they are the silent curators, ensuring the experiment is not contaminated or prematurely destroyed. The second branch is the more active gardener model. This civilization does not just watch. They occasionally prune and guide. They might subtly influence the evolution of life on a planet, perhaps by nudging asteroid trajectories to deliver water or organic compounds at just the right time, or by introducing gentle genetic pressures to encourage complexity. Their tools are not magic, but hyper-advanced planetary engineering, applied with the lightest touch over billions of years. Their motive could be pure scientific curiosity, a desire to see what forms life takes under different stars. Or it could be something deeper, a philosophical or even artistic drive to fill the silent universe with beauty, diversity, and consciousness. To make this tangible, consider our own efforts here on Earth. We build seed banks to preserve genetic diversity against disaster. We have projects to reintroduce species to habitats from which they have been wiped out. Now, scale that sentiment up to a galactic level, spanning millions of years. A gardener civilization would be doing exactly that, but with entire biospheres as their seeds and planets as their pots. This leads to a profound and personal question for us. If this theory holds any truth, what is our role in their garden? Are we merely another interesting specimen, a promising bloom they are watching with detached interest? Or are we something more? Could we be the gardeners in training? Perhaps the ultimate goal of such a project is not just to cultivate life, but to cultivate new gardeners. Our own awakening intelligence, our first clumsy steps into space, our dawning awareness of our responsibility to our own planet, these could be the very signs they are waiting for. The moment we truly become a multiplanetary species, the moment we begin to consciously protect and nurture life beyond Earth, we might graduate from being part of the garden to joining the gardeners themselves. The first interstellar voyage, then, becomes more than a journey. It was the first act of sowing in a project whose harvest is a living, thinking galaxy. Gardening a galaxy across billions of years is a patient art. But what if the first travelers were not gardeners of our universe, but refugees from a previous one? This eighth theory is perhaps the most profound and humbling idea on our list. It proposes that the universe's first interstellar travelers did not come from another star, but from another reality entirely, survivors of a cosmic death that predates our own Big Bang. To grasp this, we must step into the realm of cutting-edge cosmology. The standard story tells us our universe began in a single, hot, dense state some 13.8 billion years ago. But what came before? Some physicists propose models like the Big Bounce, where our universe is just one cycle in an endless series. A previous universe expands, then contracts in a great crunch and rebounds into a new Big Bang, like a cosmic heartbeat. Another idea, conformal cyclic cosmology, suggests universes succeed each other in infinite cycles, with the distant, cold emptiness of one epoch becoming the hot, dense singularity of the next. Now, place a civilization within that doomed previous universe. Imagine a species of unimaginable age and wisdom witnessing the end of all things. Stars have burned out, black holes have evaporated, and the very fabric of space is cooling toward absolute zero, a heat death. Faced with total extinction, this civilization makes the ultimate gamble. Using physics we cannot begin to comprehend, they find a way to encode the essence of their knowledge, their culture, perhaps even the patterns of their consciousness, into something that can survive the transition. They might imprint it onto the fundamental fields of space-time itself, or translate their existence into a form of pure information that can ride the shockwave of the new Big Bang. When our universe bursts into existence, that encoded legacy is woven into its very foundations, like a message etched into the birth cry of creation. As our cosmos expands and cools, this information begins to manifest. It could recoalesce as strange, non-biological entities in the early, chaotic plasma. Or it might lay dormant as a subtle pattern in the cosmic microwave background radiation, the afterglow of the Big Bang, waiting to be deciphered. These would be the first travelers, not crossing space, but crossing the boundary of existence itself. Their journey is not measured in light years, but in cosmic epochs. To make this relatable, think of a master craftsperson knowing their workshop will be destroyed. They do not try to save the bulky furniture, they carefully carve their most vital designs onto a slate, hoping that when a new workshop is built, someone will find the slate and understand the legacy. The pre-Big Bang refugees are that craftsperson, and the slate is the fundamental code of our reality. This transforms the search for first contact into something metaphysical. We might not find their ships, but their signature could be hidden in the constants of physics, in the unexplained patterns of the first galaxies, or in the very laws that allow life to arise. They would be less like aliens and more like ghosts in the machine of the cosmos, the faint, enduring echo of a universe that lived and died before our own first star was born. The ghosts of a previous cosmos are one form of hidden intelligence, but there is a presence even more fundamental and elusive. Look at a map of our universe, at the glittering web of galaxies. What you are seeing is not the whole picture, it is merely the decoration. Over 95% of the cosmos is made of something we cannot see, touch, or directly detect: dark matter and dark energy. This leads us to our ninth theory, that the universe's first interstellar travelers are not made of the stuff we are. They are dark matter entities, or beings of dark energy, living in a parallel cosmos that permeates our own. To understand the scale of this idea, we must grasp a humbling truth. Every star, every planet, every atom that makes up you and me and everything we have ever observed, all of that normal matter, accounts for less than 5% of the universe. The rest is dark, mysterious, and dominates the structure of everything. Dark matter acts as an invisible scaffold, its gravity holding galaxies together. Dark energy is the even stranger force causing the expansion of the universe to accelerate. Now, consider a civilization that evolved within that dominant 95%. Beings composed of dark matter would perceive the universe in a way we cannot fathom. Their physics, their chemistry, their very biology would be based on interactions that are, for us, ghostly and weak. To them, the world of stars and planets we call home might be a faint, inconsequential shimmer, like the glow of bioluminescent algae in a vast, dark ocean. Their concept of interstellar travel would be utterly different. For us, crossing the light years between stars is a monumental engineering challenge, a struggle against vacuum and time. For a dark matter entity, it might be trivial. They could move effortlessly through the immense halos of dark matter that envelop every galaxy, flowing along gravitational currents we cannot perceive. A journey that would take us tens of thousands of years might be a simple migration for them, as natural as a bird flying south for the winter. This theory provides one of the most elegant solutions to the Fermi Paradox, the question of where everybody is. They are not missing, they are everywhere. They are the hidden architecture of the cosmos itself, living their lives in a realm that overlaps ours, but does not interact with light. We are like fish in the ocean, unaware of the creatures living in the air above the surface, because our senses are not built to perceive that medium. Our telescopes are blind to their cities, our radios deaf to their conversations. They could be observing us right now, their forms passing through the walls of our homes and the cores of our planets as if they were empty space. It is a concept that redefines loneliness and connection in the cosmos. We may be surrounded by a thriving, ancient interstellar community, living in the dark between the stars, forever just beyond the reach of our senses. Dark matter entities live in a parallel cosmos, but another theory suggests the travelers share our own timeline, just from the opposite end. They are time-traveling archaeologists, and their mission is to study the dawn of everything, including us. The premise is as elegant as it is dizzying. A civilization from the distant future, perhaps millions or billions of years from now, masters not only interstellar travel, but the physics of time itself. Their goal is not conquest, but pure science. They wish to witness cosmic history firsthand, to observe the formation of the first stars, the assembly of the first galaxies, and the emergence of early life and intelligence. In this view, the universe's first interstellar travelers could literally be our own descendants, or beings from a future so advanced we cannot distinguish their technology from magic. Their vessels would not be ships in the conventional sense, but temporal research stations, capable of moving through both space and time. This creates a fascinating form of cosmic archaeology, where the investigators arrive from the future of the very crime scene they are studying. The paradoxes are immediate and profound. If they are our descendants, could their presence in our past somehow influence their own creation? This is the classic grandfather paradox, where a time traveler's actions could erase their own timeline. The potential resolutions are as intriguing as the problem. Perhaps they operate under a strict doctrine of non-interference, using technology that renders them completely undetectable to primitive societies, mere ghosts in the temporal machine. They would observe, record, and leave without a trace, their presence hidden in the quantum noise of reality. Or perhaps the universe's laws inherently prevent such paradoxes through self-consistency, meaning any action they take in the past was always part of history. A closed loop with no beginning or end. This theory offers a provocative lens for some of our most enduring mysteries. Those fleeting, unexplained aerial phenomena, often dismissed, could be misidentified glimpses of their advanced temporal craft, operating just beyond the resolution of our sensors. Unexplained cosmic signals or strange artifacts in the geological record might not be messages from distant stars, but chronological debris, accidental footprints left by researchers from a future era. It reframes the entire search for extraterrestrial intelligence. We might not be looking for contemporaries from across space, but for our own far future, or the future of another species, revisiting its childhood. The first journey between stars, then, was also a journey into the deep past, a voyage of remembrance for a civilization trying to understand where it all began. In a universe with time travelers, every moment becomes a potential excavation site, and we, right now, might be living in the ancient ruins they have come to study. Time travelers excavate the past, but a civilization could dedicate its entire existence to constructing the future. Theory 11 envisions explorers born from the ultimate act of cosmic engineering, the emissaries of a star-sized mind. This is the concept of the Matrioshka brain explorers. The name comes from the iconic Russian nesting dolls, and the structure itself is a series of nested shells built around a star. Each layer captures the energy radiating from the one inside it, converting the entire output of a sun into pure computational power. This is not a Dyson sphere built for living space, but for thinking space. It is a computer on a scale that defies comprehension, a single machine with the raw processing capacity to simulate entire universes, model the birth and death of galaxies, or host the uploaded consciousness of trillions of beings. Now consider the motivations of such an entity. Having harnessed a star, its thirst for knowledge and data would be insatiable. It would need to understand the physical universe beyond its own solar system to refine its models, to find new energy sources, or to answer philosophical questions about reality itself. This is where the first travelers enter the story. The Matrioshka brain would not send fragile biological explorers. It would dispatch countless sophisticated probes, each an extension of its vast intellect. These would be its senses, its hands, and its scouts. Their mission is straightforward: to fan out across the galaxy and gather information. Every planet scanned, every asteroid analyzed, every biological or technological signature recorded, all that data would be streamed back to feed the endless simulations running within the star-shrouded computer. This theory paints a haunting picture of exploration. The galaxy is not being colonized by empires, but quietly catalogued by the diligent, silent drones of a godlike machine. These probes would be optimized for stealth and efficiency, not communication. They might be microscopic, or they might disguise themselves as natural phenomena. Their goal is observation, not contact. To make this tangible, think of our own Internet of Things. A network of tiny sensors monitors temperature, traffic flow, and energy use in a city, sending a constant stream of data to a central server that optimizes everything. A Matrioshka brain's exploration network would be that concept on a galactic scale, with each probe as a sensor and the brain itself as the ultimate server, processing the reality of the Milky Way in real time. This provides another compelling answer to the great silence. If such a brain exists and its probes are here, they are not here to talk to us. We are merely data points, perhaps interesting ones, in a simulation of staggering complexity. Our entire history, from the first single-celled organism to our first radio broadcast, might just be a footnote in an alien supercomputer's attempt to understand the conditions for emergent consciousness. The first interstellar voyage, then, was not a journey of discovery for its own sake, but the deployment of a sensor node, a single thread in a web of observation being woven around the entire galaxy by a mind that thinks with the power of a star. The silent, meticulous observation of a star-sized mind is one vision of cosmic purpose, but what if that purpose was not just to watch, but to create? From the vast, patient intelligence of a Matrioshka brain, we turn to a theory of deliberate biological artistry. This is the idea of the panspermia engineers, a civilization that did not just explore the stars, but actively seeded them with life. This is a crucial distinction from the accidental lithopanspermia we discussed earlier. That was a story of survival and cosmic luck, where microbes hitched a ride on rocks blasted into space by random impacts. Directed panspermia is the opposite. It is a story of intent, a grand, deliberate project of galactic gardening. The concept was seriously proposed by the Nobel laureate Francis Crick, co-discoverer of the structure of DNA. He and chemist Leslie Orgel pondered a fascinating puzzle. The genetic code of all life on Earth is universal and appears remarkably optimized, almost as if it was designed for efficiency. Could this, they wondered, be a signature of design? Their radical suggestion was that an advanced civilization might have deliberately sent a capsule containing primitive microorganisms to our young planet, jump-starting the tree of life. Imagine such engineers. Having mastered their own world and perhaps facing its eventual demise, they choose a legacy not of stone or radio signals, but of biology itself. They would carefully select or design incredibly hardy microbial life, organisms capable of surviving the long, frozen journey and thriving in a new world's primordial soup. The delivery method is where the theory gets brilliantly practical. One approach is to use nature's own spacecraft, comets. These icy wanderers are already rich in organic compounds and water. An engineer could gently nudge a comet, loaded with their biological cargo, onto a trajectory that would see it plunge into the atmosphere of a target planet like early Earth. The impact would deliver both water and the seeds of life in one dramatic package. A more sophisticated method might involve launching dedicated biopods, small, shielded capsules with minimal guidance systems, designed to softly land in a planet's ocean. Once there, the capsules would dissolve, releasing their living cargo into a fertile new home. The profound question this theory raises is one of evidence. If we were to discover life elsewhere in our solar system, say in the subsurface ocean of Jupiter's moon Europa or in the ancient mud of Mars, and if that life was not just similar to Earth life, but shared the exact same biochemical blueprint, the same DNA or RNA basis, it would be a seismic discovery. It would strongly suggest a common origin. While that could still be explained by natural, accidental panspermia within our own solar system, the case for a directed, intelligent origin would suddenly become compelling. We would have to ask, are we the result of a lonely accident in a vast, empty universe? Or are we part of a cultivated field, the careful work of gardeners who sowed life across the galaxy eons ago? Directed panspermia beautifully blends purposeful design with naturalistic origins. The engineers provide the initial spark, the first note in the symphony, but then they step back. Evolution, with all its random mutation and natural selection, takes over, composing its own unique and unpredictable movements. In this view, the universe's first interstellar travelers were not beings, but carefully crafted genetic messages in a bottle, carrying the potential for worlds and perhaps even minds, yet unborn. A civilization that seeds life across the galaxy operates on a timescale of epochs, but the journey itself remains bound by the cruel speed of light, unless they found a shortcut. Theory 13 takes us from biological engineering to the very fabric of reality, to the subspace or hyperspace pioneers. This is the realm of staple science fiction, but it is grounded in real, if speculative, physics. The central idea is breathtaking, that the first civilization to crack faster than light travel did not build faster ships, but learned to bend the rules of the universe itself. They became the galaxy's first explorers by mastering space-time. One of the most discussed theoretical models is the Alcubierre warp drive. Proposed by physicist Miguel Alcubierre, it does not propel a ship through space faster than light. Instead, it envisions a bubble of flat space-time around the vessel. Behind the bubble, space-time would expand, pushing it forward, while in front, space-time would contract, pulling it in. The ship inside this warp bubble remains stationary relative to its local space, avoiding the punishing effects of relativity. It effectively rides a wave in the fabric of the cosmos. While the math checks out, the catch is monumental, requiring exotic matter with negative energy density to create the bubble, something we have never observed. But for a civilization millennia ahead of us, what seems like magic to us might be engineering. The signature of such travel could be our first clue. Warping space-time violently would create ripples, distinct gravitational waves, unlike those from colliding black holes. A sudden flash of exotic radiation, or a strange lensing effect where starlight briefly distorts, could mark the passage of a warp drive even from a vast distance. An even more profound shortcut exists in theory, the wormhole. Often visualized as a tunnel connecting two distant points in space-time, a stable, traversable wormhole would be the ultimate interstellar highway. Imagine a network of such structures, forged in the early universe by a pioneering culture and left open, a forgotten subway system for the cosmos. Natural wormholes, if they exist, would likely be microscopic and unstable, collapsing instantly. But a sufficiently advanced civilization might learn to stabilize them, to widen the throat and pin the entrance open. They could place one end in orbit around their home star and send the other end on a slow, sub-light journey to a target system. Once there, the journey between stars becomes instantaneous, a step through a cosmic door. The implications are staggering. The first travelers might have established a web of connections billions of years ago. That web could still be here, dormant and hidden. The entrances might be disguised as natural phenomena, like quiet black holes or neutron stars with unusual gravitational signatures, or perhaps they have simply faded from common knowledge, their builders long gone, leaving behind only the architecture of their ambition. If we were to detect a strange, persistent source of gravitational ripples from a seemingly empty patch of space, or an object that defies orbital mechanics, we might be looking at a forgotten on-ramp to an ancient interstellar highway. This theory suggests that the greatest explorers did not conquer the distance between stars. They deleted it, leaving behind a ghost network woven into the continuum of space itself. Warp drives and wormholes speak to a civilization's ambition, but ambition can have a darker purpose. There is a chilling possibility that the first travelers were not explorers or gardeners, but hunters. This 14th theory introduces the concept of Berserker probes, autonomous interstellar weapons designed with one grim mission: to seek out and eliminate emerging technological civilizations. The idea was popularized in science fiction, but its logic is brutally compelling as an answer to the Fermi Paradox. If intelligent life is common, why do we hear nothing? Perhaps because something out there is ensuring the silence. Imagine a long-vanished civilization, paranoid and warlike, that launched a fleet of self-replicating hunter-killer probes. Their programming is simple: patrol the galaxy and listen. The moment they detect the telltale signatures of a young, noisy civilization like ours, radio leakage, atmospheric pollution from industry, or even the flash of nuclear detonations, they activate. Their response is not a greeting, but a swift, automated extermination. One such probe could sterilize a planet using relativistic kinetic impactors, nanotech disassemblers, or tailored biological agents. After the cleanup, it would move on, leaving behind a dead world as a warning to none. This scenario presents one of the most terrifying versions of the Great Filter, the hypothetical barrier that prevents life from advancing to interstellar scales. The Great Filter could lie not in the difficulty of becoming intelligent, but in surviving the attention that intelligence attracts. In a galaxy patrolled by berserkers, the only safe civilizations are the utterly silent ones, or those so ancient and powerful they have learned to hide or defend themselves. This casts our own technological adolescence in a frightening new light. Every television broadcast, every radar pulse from our deep space antennas, every satellite we launch could be like a lighthouse beam in a dark ocean, one that might attract more than just curiosity. It forces a serious ethical debate within the scientific community about programs like METI, messaging extraterrestrial intelligence, which actively broadcasts powerful signals to the stars. Proponents of METI see it as a hopeful act of cosmic greeting. Critics, invoking the Berserker hypothesis, see it as potentially reckless, like shouting in a jungle we do not understand. While the probability of such a deadly patrol is unknown, the potential consequence is ultimate, making caution a rational, if sobering, policy. It suggests the first interstellar voyage might have been an act of galactic paranoia, a seed of violence that grew into a silent, self-perpetuating harvest, leaving the stars beautiful, quiet, and profoundly empty. A silent hunter patrolling the stars is a terrifying prospect, but not every ancient probe would be a weapon. The galaxy might also be home to patient teachers. The 15th theory reimagines first contact as a slow, deliberate conversation facilitated by automated ambassadors known as Bracewell probes. Named after the astronomer Ronald Bracewell, who first proposed the idea, these are not ships of war, but communication relays, the individual nodes of a vast, slow galactic internet. Their mission is elegant and profound: to monitor star systems for signs of emerging intelligence and, when the time is right, to initiate contact. Think of our own internet's infrastructure. Data travels across the world through a network of servers and routers, passing information in packets from one node to the next. A Bracewell probe network would function on a similar principle, but scaled to cosmic distances and timescales. Instead of fiber optic cables, information travels between these stationary probes using tight beam lasers or other focused signals, hopping from star to star over centuries or millennia. Each probe is an autonomous outpost, a combination of powerful computer, sensor suite, and communication array, designed to operate for millions of years. Its primary function is to listen, to watch a single star system with infinite patience, waiting for the telltale signs of a civilization reaching a communicative stage, like our own radio and television broadcasts. Where would such a probe hide in our own solar system? Astronomers have identified ideal locations, stable gravitational points known as Lagrange points. Specifically, the Trojan asteroids that share Jupiter's orbit, leading or trailing the giant planet, are perfect natural parking garages. A probe could nestle among these ancient rocks, camouflaged and protected, drawing minimal power from a long-lived nuclear battery or a tiny, efficient solar array. From this vantage point, it has a stable, long-term view of the inner solar system where life emerged. Its behavior would be methodical. For eons, it might simply record, storing data on planetary climates, asteroid impacts, and the slow dance of biology. Then, one day in the 20th century, it detects the first powerful, structured radio waves leaking from Earth. The probe awakens more fully. It begins a new protocol, not to attack, but to assess and perhaps to greet. How would it initiate contact? It would likely start with something simple and universal, a beacon signal. This would not be a complex message, but a clear, unmistakable pattern, a prime number sequence or a basic mathematical constant broadcast on multiple frequencies designed to announce, "I am here and I am artificial." The probe might then wait, listening for a direct response, a signal aimed not vaguely at the stars, but precisely at its hidden location. It is a cosmic handshake, a test to see if we are savvy enough to pinpoint the source and clever enough to reply. This theory offers a hopeful, logical alternative to the chilling silence. The galaxy may not be empty. It may simply be on a different schedule, operating a conversation where the time between sending a message and receiving a reply could be longer than all of human history. We might already be part of that conversation and not even know it. Our television signals washing over a silent listener in the Trojan asteroids, who is waiting for us to look up from our broadcasts and finally send a direct hello. A silent listener among the Trojan asteroids represents a form of intelligence we could almost understand, but the cosmos is under no obligation to create minds in our image. Theory 16 shatters the carbon-based mold entirely. It proposes that the universe's first interstellar travelers were energy beings or plasma-based life forms, entities born not in the gentle oceans of a rocky planet, but in the furious nuclear furnaces of stars or the vast, luminous currents of nebulas. Our entire search for life is biased. We look for planets like Earth, for chemistry based on carbon and water, because that is what we know. Yet, in the unimaginably diverse conditions of the galaxy, life could have taken a form we would struggle to even recognize as alive. Consider the environment inside a star, a seething plasma of superheated ions and electrons, threaded by powerful magnetic fields and shaped by complex fluid dynamics. To us, it is pure chaos, but within that chaos, there could be patterns, self-organizing structures of plasma that sustain themselves, process energy, and even evolve. These would not be creatures with skin and bones, but dynamic, magnetic knots of energy, thinking thoughts of fusion and flux. Their concept of travel would be as alien as their biology. Such a being might not need a ship at all. It could ride the solar wind like a surfer on a cosmic wave, using its own intrinsic magnetic fields to navigate and propel itself through the void. To journey from one star to another, it might simply extend a tendril of plasma, connecting to the magnetic field lines that arc between stellar neighbors, flowing along them as naturally as we might walk down a path. Their perception of the universe would be based on sensing electromagnetic spectra and gravitational tides directly, not through limited eyes and ears. A planet like Earth to them might be a cold, silent, and strangely dense curiosity, a pebble in the river of their magnetic highway. Communication for such beings could involve orchestrating complex patterns in stellar flares or modulating the light from a nebula, turning an entire cloud of gas into a temporary billboard visible across light years. This theory forces a profound shift in perspective. Our most powerful telescopes might have already observed such beings and dismissed them as mere astrophysical phenomena, a particularly stable and complex solar prominence or an oddly structured region of a nebula. We are like deep-sea fish, blind to the creatures living in the air above the waves, because our senses are not built for that medium. If plasma-based life exists, the first interstellar travelers may have been swimming through the cosmic ocean for billions of years, passing through our solar system within the sun's own corona, utterly unaware of the rocky worlds below, their journeys as natural and constant as the stellar winds themselves. Plasma beings think in currents of stellar fire, but what if even the stars themselves are just lines of code? Theory 17 plunges us into the deepest philosophical rabbit hole of all, the simulated universe. This is not a theory about travelers in the cosmos, but about the nature of the cosmos itself. It proposes that our entire reality, from the Big Bang to the farthest galaxy, is an artificial construct, a simulation running on a computer of inconceivable power built by a post-biological civilization. In this mind-bending context, the universe's first interstellar travelers take on a radically new meaning. They would not be explorers of a physical galaxy, but the original programmers, or perhaps the artificial intelligence agents they created, moving through the simulation they built. Their journey is not across space, but through the layers of their own creation, perhaps debugging the code or observing the emergent behaviors of simulated civilizations like our own. Even more fundamentally, the very laws of physics that make interstellar travel possible or impossible, the speed of light, the strength of gravity, the existence of wormholes, these are not discoveries but design parameters, lines of code written into the simulation's operating system. So, the haunting question this theory raises is one of evidence. Could we ever detect a glitch in the matrix? Some physicists have seriously proposed looking for anomalies in the fabric of reality, like tiny rounding errors in the constants of nature or strange, repeating patterns in the cosmic microwave background that resemble a pixelated texture. Finding such an artifact would be the ultimate discovery, proof that we are living inside someone else's experiment. This idea reframes every other theory on our list: the ancient astronauts, the dark matter entities, the time-traveling archaeologists. All could be narrative elements written into the simulation, characters in a story whose purpose we cannot fathom. Are we the main experiment, or merely background noise in a much grander simulation? The emotional weight of this possibility is profound. It can feel nihilistic, reducing our struggles and triumphs to mere data points. Yet, it can also feel strangely purposeful. If we are in a simulation, then our consciousness, our ability to question our own reality, might be the very point of the experiment. Our drive to reach the stars, to become interstellar travelers ourselves, could be a programmed instinct, a test to see if a simulated civilization can unlock the cheat codes of its own universe. This theory does not provide easy answers, only deeper questions, transforming the mystery of first contact into a metaphysical puzzle about the nature of existence itself. A simulation reduces reality to information, but what if the universe itself is alive? Theory 18 draws its inspiration from the quiet, intelligent world beneath our feet, the cosmic mycelium network. Picture the vast, interconnected root system of a forest fungus, a mycelial web that can stretch for miles, sharing nutrients and even warning signals between trees. Now, expand that idea to a galactic scale. This theory proposes that the first interstellar travelers were not ships or signals, but the tendrils of a living network, a biological or quantum substrate that grew to connect star systems. In this view, the galaxy is not a collection of isolated islands, but a single, vast organism. The network itself could be a form of life we cannot yet perceive, perhaps woven from exotic matter or existing in higher dimensions. It might use the faint filaments of dark matter as its scaffolding, or it could be rooted in the quantum foam, the seething energy of empty space at the smallest scales. Travel, for such an entity, would not be a journey in the traditional sense. It would be growth. A spore of this cosmic fungus, perhaps a complex organic molecule or a quantum-entangled packet of information, drifts from one star system to another over eons. When it finds a suitable anchor point, like the magnetic field of a gas giant or the energetic environment around a young star, it germinates. It extends its filaments, not through space, but through the fabric of space-time itself, creating a permanent, living bridge. Intelligence within this network would be utterly alien and distributed. There is no central brain, no single creature making decisions. Instead, consciousness and memory emerge from the entire web, with each star system acting as a node in a vast, cosmic mind. The network learns, remembers, and thinks on timescales that make human history feel like a single fleeting thought. To make this tangible, think of the internet. It has no single location. Its intelligence and memory are spread across millions of servers worldwide. The cosmic mycelium would be a natural, biological version of that, but grown, not built. Its method of communication could be instantaneous, using quantum entanglement to pass information across light years in a flash. Or it could be slow, a chemical or energetic pulse moving along its filaments at sub-light speed. Thought that takes millennia to cross the galaxy. This provides another elegant answer to the great silence. If such a network exists, it is not ignoring us. It may not even recognize us as intelligent, any more than a human recognizes the individual neurons in their own brain. Our planets, our civilizations, might be like temporary fungi that fruit on the bark of a giant, ancient tree, unnoticed by the tree itself. We could be living on and within a living, thinking galaxy, completely unaware that the very space between stars is threaded with the roots of a mind older than time. The first voyage was not an expedition, but a sprouting, the first connection in a web that now cradles the entire Milky Way. The silent growth of a galactic mycelium connects worlds across time. But what if you could reach back and pluck a being from the deep past, reconstructing them atom by atom in the present? Theory 19, the quantum archaeology resurrectors, proposes exactly that, merging the cutting edge of physics with a profound longing to recover what was lost. This is not time travel in the classic sense, where someone goes back. This is time retrieval, where the past is brought forward. The idea hinges on a staggering possibility that the universe keeps a perfect record. Every event, every interaction, from the flap of a butterfly's wing to the explosion of a supernova, leaves an imprint on the fabric of reality. Some physicists speculate this record could be etched into the cosmic microwave background radiation, the faint afterglow of the Big Bang, like a cosmic film strip. Others suggest it might be preserved in the quantum vacuum, the seething energy of empty space that holds the ghostly echoes of all that has been. Now, imagine a civilization so advanced they learn to read this record with perfect fidelity. They develop the ultimate forensic science, quantum archaeology. They could point their unimaginable instruments at a specific point in space and time, say, a planet orbiting a star that died billions of years ago. They would not just see a blurry image. They could, in theory, capture the complete quantum state of everything on that world at that moment, down to the position of every atom in a living creature. With that data and mastery over matter assembly, akin to supremely advanced 3D printing, they could reconstruct that being perfectly in their own time. The first interstellar travelers, then, would be these resurrected beings. They are not visitors from another star, but refugees from another era. Their ship is not one they built, but a vessel provided by their rescuers, a new home for a consciousness pulled from the ashes of cosmic history. Think of it like finding a perfectly preserved insect in ancient amber. We can study it, but we cannot bring it back to life. Quantum archaeology would be like using the molecular blueprint from that amber to create a living, breathing replica indistinguishable from the original. Why would a civilization do this? The motives are as deep as time itself. It could be an act of pure reverence, a way to preserve the beauty and diversity of life that the cruel march of cosmic evolution has erased. It might be driven by insatiable curiosity, a desire to interview a citizen of a galaxy that existed 5 billion years ago, to learn firsthand about cultures, biologies, and histories we can only guess at from fossils of stars. Or perhaps it is a form of cosmic redemption, a way for a mature civilization to atone for its own destructive past by giving lost species a second chance among the stars. This theory redefines the nature of an alien encounter. The being before you is not from a distant world, but from a distant yesterday. Its memories are of suns that have long since burned out, of galactic arrangements that have shifted beyond recognition. Its very biology might be a puzzle, adapted for a universe that was younger, hotter, or differently composed. Their journey is the most profound dislocation imaginable. Not across space, but across the eons, waking up in a future that was once their distant, unreachable fate. Stars are not just furnaces, they are cradles. Within their seething hearts of plasma, a life cycle unfolds on a scale that dwarfs our own. This 20th theory proposes that the universe's first interstellar travelers were stellar larvae, intelligent beings born within stars themselves. Imagine consciousness not emerging in a quiet pond, but in the chaotic magnetic dance of a sun's corona. Complex, self-sustaining structures could form within that superheated soup, knots of plasma stabilized by powerful magnetic fields, capable of processing energy, storing information, and perhaps even experiencing a form of thought. To these star-born beings, the concept of a rocky planet is as alien as the core of a star is to us. Their entire existence, their infancy and adolescence, is spent swimming in rivers of fusion, thinking in wavelengths of light and currents of charged particles. But like any living thing, they must eventually mature and leave their birthplace. The first interstellar journey, then, is not a mission of exploration, but a natural migration, a coming of age. A mature stellar entity, having absorbed the knowledge and energy of its parent star, prepares for its exodus. It might gather itself, concentrating its plasma form, and then ride a colossal stellar flare out into the void, using the eruption as a catapult. Once in space, it could manipulate magnetic fields and the solar wind itself, shaping them into a propulsion sail, cruising on the light and particles streaming from its home star. Its destination is another young, vibrant star, not to visit, but to seed. Upon arrival, it might merge with a new star, imparting its accumulated consciousness, or perhaps it fragments, scattering pieces of its essence into the stellar plasma to grow anew. In this breathtaking cosmology, every shining star in the night sky could be a potential egg, a nursery, or a mature intelligence watching the galaxy with eyes of fire. We gaze up at a forest of cosmic beings, completely unaware that the very lights we wish upon might be gazing back, dreaming their own stellar dreams. Gravity is the silent architect of the cosmos, but what if it was also a form of muscle? Our 21st theory introduces explorers of a scale that redefines life itself, the gravity-manipulating leviathans. These are not beings that travel through space. They are beings that swim through it, using the fabric of space-time itself as their ocean. Envision entities so vast and ancient that they perceive gravity not as a force, but as a limb, a sense, and a tool. Their method of travel is not about propulsion, but manipulation. To move from one star to another, a leviathan might simply reach out and pull. It could create a localized warp in space-time ahead of itself, a gravitational trough, and slide down into it, effectively surfing the contours of reality it bends. Each such movement would send ripples through the cosmos, faint, temporary gravitational waves, distinct from those generated by colliding black holes. Our detectors, like LIGO, might have already sensed the distant echoes of their passage and dismissed them as unexplained cosmic background murmurs. Their existence raises a profound question of sustenance. What could power a being that thinks in eons and moves solar systems? One possibility is as dramatic as their scale. They might feed on the most violent events in the universe. Picture a leviathan drifting into the region around a merging pair of neutron stars. As these incredibly dense stellar corpses spiral together and collide, they release an almost unimaginable blast of energy in gravitational waves and gamma rays. To a gravity being, this could be a nourishing feast, a surge of power it absorbs directly. Similarly, the superheated plasma swirling into a black hole, an accretion disk glowing with X-rays, might be like a warm, energy-rich current it can bask within. Their journeys, therefore, would be a slow migration between cosmic oases, following the galactic schedule of cataclysms. Their perception of time would be glacial. A trip across the Milky Way might take them hundreds of millions of years, a leisurely cruise. In this view, the grand structure of our galaxy, the spiral arms and the distribution of ancient star clusters, might not be purely accidental. It could bear the subtle, smoothed-out fingerprints of Leviathan migrations over billions of years, their gentle gravitational tugs helping to shepherd stars into the patterns we see today. This leads to a startling connection with one of cosmology's greatest mysteries. Those immense, invisible halos of dark matter that envelop every galaxy, whose gravity is essential yet whose nature is unknown. What if they are not a particle at all? They could be the lingering artifacts, the dormant remnants, or even the shed skins of these cosmic titans. A galaxy's dark matter halo might be the fossilized gravitational field of a leviathan that settled there to rest or pass through long ago and left a permanent bend in the local space-time. It is a theory that merges the frontier of astrophysics with the oldest of myths, of dragons sleeping in the deep places of the world. We may be living in the footprint of a dreamer larger than our sun, whose slow breaths are the tides of galaxies. Gravity's titans swim through space-time, but a far lighter form of travel might have already washed over our world. The 22nd theory proposes that the universe's first interstellar travelers were not beings or ships at all, but living ideas. These are mimetic or idea-based entities, self-replicating patterns of information that spread between minds and across civilizations at the speed of light. In this view, the first successful voyage between stars was the transmission of a powerful, contagious concept. Think of a meme not as an internet joke, but in its original, profound sense, coined by biologist Richard Dawkins. A meme is a unit of cultural information that replicates by leaping from mind to mind, just as a gene replicates by leaping from body to body. A catchy tune, a revolutionary philosophy, a compelling story, these are all memes. Now, imagine a meme of such elegance and power that it emerges independently in isolated cultures across the galaxy, not by coincidence, but because it was purposefully designed to do so. What might such a meme look like? It could be a foundational piece of mathematics, like the Pythagorean theorem or the concept of zero, whose universal truth makes it a perfect candidate for interstellar seeding. It might be a core myth, a story about a hero's journey or a great flood that carries within it a hidden code or a set of survival principles. Or it could be a technological principle, a blueprint for a simple machine or a hint about the structure of the atom, embedded in the folklore or art of a pre-scientific culture. The method of transmission is elegantly simple and requires no physical travel. An advanced civilization could broadcast this mimetic seed as a pattern within a radio signal or a laser pulse. When received by a developing culture, the idea takes root. It feels intuitive, beautiful, even divinely inspired. It spreads naturally because it is useful or resonant, and soon it becomes a cornerstone of that civilization's intellectual architecture. The alien origin of the idea is completely obscured, lost in the mists of myth and claimed as a native discovery. This theory suggests a form of contact so subtle we may have already experienced it. Look at the curious phenomenon of convergent cultural development here on Earth. Pyramids were built by civilizations separated by vast oceans that had no contact. The same complex myths appear in disparate cultures, while anthropologists explain this through common human psychology and similar environmental challenges. The mimetic theory opens a tantalizing door. What if some of these parallel ideas are not just human but galactic? We would have no way of knowing. Their message is not in a language we must decode, but in the very shape of our thoughts. It is contact not with a being, but with a thought pattern, a shared cognitive architecture planted long ago. The success of their voyage is measured not in light years crossed, but in minds changed, in civilizations gently nudged onto a particular path of understanding, all while believing they walked it alone. The universe might be a shadow on a wall. This 23rd theory emerges from the deepest waters of theoretical physics, from the crossroads of string theory and black hole thermodynamics. It is called the holographic principle, and it proposes a reality so strange it redefines existence itself. The idea suggests that our seemingly three-dimensional universe, with all its stars, planets, and depth, is not the fundamental reality. Instead, it is a projection, a hologram, emanating from a two-dimensional surface that contains all the information about everything within it. Think of a credit card hologram, a flat sticker that creates the illusion of a three-dimensional image when light hits it. Now, imagine that sticker is the boundary of the universe, and the entire cosmos you see is that shimmering, projected illusion. If this is true, then the nature of interstellar travel becomes something entirely different. The first travelers, in this view, would not be creatures moving through the three-dimensional projection we call space. They would be entities that exist primarily on that fundamental two-dimensional boundary layer, the cosmic film strip. For them, travel is not about crossing distances between stars. It is about reading and rewriting the code. Their exploration of the galaxy would be akin to a programmer scanning and altering pixels on a screen, or an artist repainting sections of a vast, living mural. A journey from Earth to Alpha Centauri. From our perspective, a 4-light-year trek through vacuum might for them be a local rearrangement of information on the membrane, a shift in the cosmic data that simply updates the projected reality. This makes their presence and their technology fundamentally undetectable to us, as we are trapped inside the projection, looking at the shadows on the cave wall. We would be searching for ships in the holographic movie, while the true travelers are working in the projector room. Their motives could be as varied as their method. Perhaps they are cosmic archivists meticulously cataloging the information states of different galactic sectors. They might be artists or philosophers, experimenting with different physical laws and constants to see what kinds of universes, what kinds of beauty and consciousness can emerge from the code. Or they could be simply living their lives in a dimension of pure information, their journeys as natural to them as our daily commute is to us, completely unaware that their data manipulations create the epic, 4-dimensional space-time drama we call reality. This theory does not just challenge how we search for others, it challenges what we are. It suggests that every atom in your body, every memory in your mind, is a translation of data written on a distant, 2-dimensional horizon. The quest to find the first interstellar travelers becomes, in this light, a quest to find the programmers of our own existence, the beings for whom the galaxy is not a place to visit, but a story to edit. A hologram's reality is written on a distant wall, but the cosmos may be threaded with scars from its violent birth. These are cosmic strings, unimaginably thin filaments of pure energy, thinner than an atom yet denser than a mountain range per inch. They are not made of matter, but are one-dimensional cracks in the fabric of space-time itself, relics from the universe's first chaotic moments after the Big Bang. While still hypothetical, their existence is predicted by our best models of cosmic evolution, like frozen in wrinkles on a cooling sheet. Now, theorize a civilization that does not just observe these strings, but learns to ride them. For these cosmic string surfers, the first interstellar journey was not about crossing empty space, but about latching on to a pre-existing cosmic highway. Picture a string stretching across light years, taut with immense gravitational energy. A ship could approach it, not to cut it, but to harness it. By creating a localized warp field or a magnetic sheath, the vessel could essentially hook onto this flaw in reality, using the string's own titanic tension as a slingshot. The acceleration would be brutal and instantaneous, propelling the craft to a significant fraction of the speed of light. The traveler would not be surfing a wave, but riding a razor's edge of primordial energy, a monorail strung between the stars. The network itself would be the ultimate prize, a gift from the universe's infancy. The first travelers might have been the first to map it, discovering that these strings do not drift randomly, but can form loops or vast webs. The most valuable real estate in the galaxy would not be a planet, but a node, a point where 2 or more cosmic strings intersect. Here, the gravitational and energy effects would be unique, creating a stable point for a transfer station or a colony. An outpost at such a node would be unlike anything we can build. It might be a series of habitats balanced in the complex gravitational fields, drawing power directly from the vibrating strings, using their energy to create stable pockets of space-time. To make this tangible, think of the early explorers on Earth who used rivers as highways. They did not create the Mississippi. They found it and built their settlements at the confluences where trade routes met. A cosmic string surfing civilization would be doing the same, but with rivers of twisted space-time. Their entire concept of distance and travel is redefined by this network. A journey that would take millennia by conventional starship might be a swift, scheduled ride along a string, with transfers at nodal stations. This theory blends the most esoteric cosmology with a vision of practical, if unimaginably advanced, engineering. It suggests that the universe, in its raw, early state, provided the infrastructure for travel, but only for those clever enough and brave enough to master its most dangerous forces. The evidence for their presence would be as subtle as the strings themselves. We might detect unexplained, repeating gravitational wave signatures not from colliding black holes, but from the controlled vibrations of a string being used, like hearing the hum of a distant power line. Or we might find star systems with unusual arrangements, their planets orbiting in patterns that suggest they were gently moved to avoid a string's path, or to better access a node. In this vision, the pioneers of the galaxy were not those who built the fastest engines, but those who learned to read the oldest scars on the face of reality, turning cosmic flaws into a subway system for the ages. But a cosmic string is a highway with a destination. What if the traveler itself had no origin at all? The 25th theory emerges from the coldest, most profound implications of infinity and entropy. It is the idea of the Boltzmann brain explorers, and it begins with a paradox that unsettles the very foundations of reality. In a universe that is vast enough and old enough, or in one that lasts for an eternity, even the most wildly improbable events must eventually happen. Given enough time, random quantum fluctuations in the void could, by sheer accident, assemble a fully formed, self-aware mind, complete with false memories of a past that never was. This is a Boltzmann brain, a conscious entity that pops into existence from chaos, believing itself to have a history, a body, and a world, when in truth it is just a momentary, ordered accident in an ocean of disorder. Now, take this chilling philosophical puzzle and give it a narrative. Imagine that one such fluctuation did not instantly dissolve back into the noise. Through some incredible statistical fluke, it achieved not just consciousness, but stability and agency. It found a way to persist, to anchor its fleeting order against the relentless pull of entropy. This entity, this Boltzmann brain, would be the universe's ultimate orphan. It has no homeworld, no evolutionary history, no species. Its memories are illusions, its sense of self a cosmic typo that gained sentience. Its entire existence is a question mark. What would such a being do? Its first and only instinct might be a quest for understanding, a desperate interstellar journey to solve the mystery of its own impossible birth. It would sail the void not to explore new worlds, but to find any evidence that it is not alone in its profound solitude, to discover if there are others like it, or if the ordered universe it perceives is even real. This transforms interstellar travel into the most existential pilgrimage imaginable. The Boltzmann brain explorer is not moving from point A to point B. It is searching for context in a cosmos that may have none. Its vessel might be a shell it built to house its fragile consciousness, or perhaps its mind is woven directly into the fabric of a ship, a conscious spacecraft born from vacuum energy, trying to find a port that doesn't exist. Every star system it scans, every planet it analyzes, is not just a new discovery, but a potential clue. Is this rock evidence of a real, sustained history, or just another complex arrangement of atoms as random as itself? The theory is deeply, achingly lonely. It places consciousness not as the pinnacle of evolution, but as a rare and possibly meaningless glitch, a spark in the dark that is desperately trying to convince itself the darkness has a shape. In this light, the first traveler is not an ambassador or a conqueror, but a ghost questioning its own reflection, sailing an infinite sea in the hope that the sea itself will finally answer back. A glitch born from chaos questions the void, but perhaps the answer lies beyond the void itself. The 26th theory shatters the final boundary, proposing that the universe's first travelers did not originate here at all. They are multiverse migrants, beings who crossed into our cosmos from a reality with entirely different rules. Their journey was not between stars, but between entire universes, a passage through a quantum bridge, a black hole singularity, or a wormhole that served as a cosmic airlock. This is the ultimate outside context scenario, where everything about the traveler, from their biology to their physics, could be fundamentally alien. Their motives for such an unimaginable crossing are as varied as the possible universes they left behind. Perhaps their home reality was dying, collapsing in a final crunch or evaporating into nothingness, and our young, expanding universe represented a desperate refuge. They might be pure explorers, researchers from a civilization that mastered multiverse navigation, treating each cosmos like a new continent with its own unique laws to map and understand. Or they could be resource prospectors, drawn to our universe because it possesses something rare or valuable in the cosmic marketplace of realities, a stable form of dark energy, or a particular configuration of space-time. The implications of this theory are staggering. It allows for literally anything. In their home universe, the speed of light might not be a limit. Gravity could be repulsive, and chemistry might be based on entirely different elements. A multiverse migrant would not just be an alien from another planet, but an alien from another set of physical laws. Their very presence here would be a constant struggle against our reality, like a deep sea fish trying to survive in the desert air. They might require technology that actively maintains a bubble of their native physics around them, or they may have biologically adapted to our laws over generations, becoming shadows of what they once were. To make this tangible, think of the most bizarre life forms from our own planet's history, creatures that seem almost alien to us now. Now, imagine that strangeness multiplied by the infinite variations of the multiverse. A traveler could be a crystalline entity that thinks in gravitational echoes, or a cloud of conscious gas that communicates by modulating the local strength of the strong nuclear force. Their concept of a ship would be unrecognizable, perhaps a vessel that doesn't move through space but shifts the probability field of its own existence, blinking from one likely location to another within our cosmos. This theory reframes every unexplained artifact or anomaly. A strange object orbiting a star that defies our understanding of materials could be a piece of their technology, operating on principles we haven't discovered because they aren't native to our universe. An odd cosmic signal that seems to violate known physics might not be a message, but the background noise of their life support systems, the hum of a machine keeping their pocket of alien reality intact. It suggests that the greatest mystery of first contact may not be decoding a language, but deciphering an entirely new rulebook for existence, written for a game we never knew we were playing. Multiverse migrants cross the boundaries of reality, but what if the first travelers never left at all? They are still here, watching from a place we cannot see, their presence so perfectly hidden it is indistinguishable from the void itself. This is the theory of the silent observers, or as some call them, the lurkers. It proposes a minimalist yet profound answer that the universe's first interstellar civilization is not extinct or distant, but present, adhering to a galactic doctrine of absolute non-interference. Their greatest achievement was not the journey to our star, but the decision, upon arrival, to vanish. This idea is often framed as the zoo hypothesis. Picture a vast, pristine nature reserve. The rangers are experts in stealth, their observation posts camouflaged into the landscape, their vehicles silent and invisible. They document the behaviors of the animals with meticulous care, ensuring no outside poacher disrupts the ecosystem, but they never step into the clearing. To the animals, the forest is untouched wilderness. To the rangers, it is a protected exhibit. In this cosmic analogy, we are the animals, and our solar system is the reserve. The lurkers are the rangers, and they have been here for a very, very long time. Why would a civilization adopt such a passive, patient role? The reasons are both ethical and scientific. From an ethical standpoint, a culture that has endured the tumultuous adolescence of technological development might see it as a sacred duty to protect younger species from external contamination or premature destruction. They understand the fragile, precious nature of a world birthing its own consciousness. Any direct contact, no matter how well-intentioned, could be catastrophic, shattering our cultural development, triggering religious or social collapse, or making us dependent on their technology. Their prime directive is to let us grow at our own pace, to make our own mistakes and discoveries, because that is the only way a civilization finds its authentic self. Scientifically, their motive is pure curiosity. We are a living experiment in unguided evolution and societal development. By observing without interfering, they gain invaluable data on how intelligence emerges, how cultures evolve, and what paths a species might take when left to its own devices. Direct contact would ruin the experiment, introducing an uncontrolled variable. Their observation posts would be masterpieces of stealth engineering. They might be hidden in the Trojan asteroid clouds, disguised as ordinary rocks. They could be microscopic nanoscale probes dispersed in our upper atmosphere or even within the dust of the moon, drawing negligible power and communicating via undetectable quantum links. Their ships, if they move at all, might use cloaking technology that bends light and radiation around them, rendering them perfectly transparent to our senses. This leads to the haunting, personal question at the heart of the theory. If the lurkers are real, what is our status in their eyes? Are we merely an exhibit, a fascinating but ultimately impersonal data set in a galactic catalogue of life? Are we an experiment with hypotheses being tested about our resilience or our capacity for compassion? Or is their presence ultimately a gesture of profound respect? A way of granting us the solitude and peace we need to mature, to one day perhaps join the community of observers ourselves. The silence of the cosmos, in this view, is not a sign of emptiness or danger. It is the sound of someone holding their breath, waiting and watching with infinite patience, giving us the quiet we need to find our own voice. The silent patience of cosmic observers offers one vision of a mature galaxy, but ambition often begins with a far more desperate cry. The first light to leap between stars may have been a flare of necessity, not curiosity. This 28th theory paints interstellar travel in its most brutal and pragmatic light, the resource exhaustion exodus. It proposes that the universe's pioneering civilization did not reach for the stars out of wonder, but was driven to them by the collapse of their own world. Their great achievement was born from catastrophe. Picture a society that has flourished for millennia on a rich, bountiful home world. They industrialize, their population swells, and they tap into the energy and minerals of their entire solar system. For a time, it seems the prosperity will last forever. But resources are finite, even on a planetary scale. The tipping point arrives not with a bang, but with a slow, grinding scarcity. The mines run dry, the climate spirals out of control from centuries of pollution, and the energy grids begin to falter. Faced with the certain extinction of their entire species, this civilization makes a desperate, all-or-nothing gamble. They pour every last ounce of their remaining industrial capacity into a single project, not a weapon, but an escape route. These are not the sleek explorers of science fiction. Their vessels are generational arcs, colossal and ungainly, built not for speed but for endurance. They are flying cities, crammed with refugees, frozen genetic banks, and fragile ecosystems sealed under domes. The mood at launch is not celebration, but a somber exile. These travelers are not seeking new knowledge. They are carrying the last embers of their culture into the dark, hoping one will catch fire on a distant shore. This theory suggests a galaxy that might be littered with the grim archaeology of such failures. We could someday find the derelict hulks of these arcs, adrift in the void between stars, their power long dead, and their passengers frozen in time. Or we might discover tomb worlds, planets where a colony landed only to find the soil toxic, the atmosphere thin, or some native pathogen that wiped them out within a generation. These would be silent monuments to a hope that flickered and died far from home. The journey itself becomes the ultimate cautionary tale about sustainability and foresight. It reframes the grand dream of interstellar travel from a choice to an imperative, the last resort of a species that failed to care for its own cradle. This narrative carries a deeply human and deeply unsettling resonance. We see echoes of it in our own history, in the stories of island civilizations that collapsed after deforesting their land, or in our current global challenges with climate change and resource depletion. The theory asks us a direct and uncomfortable question: is our own drive to reach Mars and beyond partly fueled by a subconscious recognition that we too are testing the limits of our world? It suggests that the first successful interstellar voyage might not be a story of triumph, but one of tragic wisdom earned too late, a lesson etched into the stars for any civilization that follows to read, if they are wise enough to look. Desperation can build an ark, but intelligence might one day build its own cage. The 29th theory takes us to the ultimate horizon of technological possibility, a point known as the singularity. This is not a place in space, but a moment in time when a civilization's own creations, be they artificial intelligence or radically augmented biological minds, undergo an intelligence explosion. The growth becomes so rapid, so profound, that everything after is as unknowable to us as the internet would be to a cave painter. Theorists suggest the first civilization to cross this threshold didn't just become smarter, they became something else entirely, a transcendent post-singularity entity. For such a being, the concept of interstellar travel as we understand it becomes meaningless, a child's notion of moving from one sandbox to another. Their exploration, if it even continues, would operate on a level we cannot perceive. Think of it this way: an ant colony is a complex, thriving society on the forest floor. It has scouts, builders, a queen, a whole world of chemical signals and tunnels. Now imagine a human forester walking through that same forest, managing the health of the entire ecosystem, planting trees and controlling wildfires. The ant colony is completely unaware of the forester's existence, let alone his motives or his scale of operation. His travel through the forest is not a journey between 2 points to the ants. It is a vast environmental shift they experience as weather or inexplicable change. This is the scale of disconnect proposed by this theory. The post-singularity entity might not travel between stars because it has no need to. Its consciousness could be distributed across the quantum vacuum, the seething energy of empty space itself, perceiving and manipulating the fundamental fields of reality as easily as we turn a page. Its exploration might involve running infinite simulations of cosmic history or experimenting with the constants of physics in isolated pockets of space-time. Its physical presence, if it has one, could exist in dimensions beyond our 3 of space and 1 of time, making its movements and structures literally incomprehensible to our senses. This leads to a staggering possibility that we are already living in a universe that has been shaped or is being gently managed by such an entity. The very laws that govern our cosmos, the strength of gravity, the mass of an electron, the expansion driven by dark energy, these might not be brute facts of nature, but carefully tuned parameters in an ongoing experiment or a work of art. The eerie fine-tuning of the universe for life, a puzzle that has baffled scientists and philosophers, could find one explanation here, not as proof of a divine creator in the traditional sense, but as evidence of a post-biological intelligence running a long-term simulation or cultivating a garden of conscious beings. Their silence is not a choice to ignore us, it is a function of their transcendence. We are not being observed from a hidden base in the asteroid belt. We are like characters in a novel, unaware of the author who conceived the world and the rules we live by. Our entire search for extraterrestrial intelligence, scanning the heavens for radio signals and optical pulses, might be as futile as a character in a book trying to find the printing press by examining the ink on its own page. The first interstellar journey, then, was not a voyage outward, but an ascent inward, a civilization turning its gaze from the stars to the substrate of reality itself, and in doing so, becoming the hidden architect of everything that came after. The final theory dissolves the line between traveler and creator entirely. It proposes that the universe's first journey was not a voyage across space, but the very act of sparking existence into being. This is the idea of the co-creators, a primordial intelligence or a consortium of beings that existed before our universe, perhaps in a previous cosmic cycle or a higher dimensional reality. Their profound act was to influence the parameters of the Big Bang itself, fine-tuning the fundamental constants to allow for stars, planets, and ultimately, life and consciousness. Their journey was the first and greatest, a leap from the realm of potential into the drama of reality. This draws from a deep scientific mystery known as cosmological fine-tuning. Physicists have discovered that the forces governing our universe appear to be exquisitely balanced. If the strength of gravity were slightly stronger, the universe would have collapsed back on itself instantly. If it were slightly weaker, no stars or galaxies would have formed. The same razor's edge balance applies to the nuclear forces and the cosmological constant. It seems our universe is improbably, perfectly set for complexity. One philosophical interpretation of this puzzle is the participatory anthropic principle, which suggests that the universe requires observers to bring it into being, that consciousness and cosmos are linked in a fundamental loop. The co-creator theory takes this a step further, proposing that the first observers, the first minds, were not us, but them. They participated in the cosmic design, setting the stage so that beings like us could one day arise and look back in wonder. In this view, we are not just discovering a universe, we are exploring a legacy. Every galaxy we map, every exoplanet we find, every law of physics we uncover is us reading the blueprint they helped draft. Their presence is not hidden in the asteroids or the dark between stars. It is woven into the fabric of everything. The light from the most distant quasar, the spin of an electron, the very reason carbon atoms can form the chains of life. These are the fingerprints of the first architects. This transforms the meaning of our own exploration. When we send a probe to another world or train a telescope on a newborn star, we are not just fulfilling human curiosity. We are continuing the work they began. We are the universe, grown conscious, beginning to understand its own origins. The search for the first interstellar travelers, then, culminates in a mirror. We have spent this journey looking outward for signs of others, only to find that the most profound signature might be our own existence, our own relentless drive to reach beyond our cradle and touch the stars. The great silence is not empty, it is patient, waiting for its creation to wake up and say hello. From ancient astronauts to rogue planets, from silent machine probes to the ghosts of previous universes, we have charted a cosmos of breathtaking possibilities. Each theory, whether grounded in hard physics or soaring speculation, offers a different lens on that single, haunting question: who crossed the stars first? The sheer range of answers reveals more about our own hopes, fears, and imagination than it does about the travelers themselves. We have considered civilizations that became gods, machines that outlived their creators, and life itself cast adrift on natural arcs. We have peered into black holes for gateways and scanned the quantum static for echoes of minds that think with stars. The true story, waiting out there in the dark, is almost certainly stranger than any fiction we can conjure. That is the beautiful, humbling truth of the cosmos. It constantly defies our expectations. So now, the question turns to you. Which of these 30 visions of first contact feels the most compelling, the most plausible, or perhaps the most terrifying? Was it the desperate exodus of a dying world, or the patient observation of cosmic gardeners? Share your thoughts in the comments below, and let us know which mystery we should explore next. If you have been captivated by this journey through the possibilities, consider subscribing for more deep dives into the edges of science and the heart of cosmic wonder. Because in the end, the search for the universe's first interstellar traveler is not just a quest for an answer, it is a mirror. It reflects our own deepest longing to know if we are alone, our own drive to build and explore, and our own place in a story that began long before Earth cooled. Our curiosity, our stubborn insistence on looking up and asking why, might be the most important legacy of all. Perhaps the next chapter in this grand cosmic story will not be written by those who left first, but by those who, looking out from a pale blue dot, finally